Hey everyone, welcome back to the channel. You're about to enhance your skills in C programming and boost your coding ability. Understanding if statements. Learn how to use if statements to control your program's flow. Using else and else if. These statements help create more complex decision making. Switch case statements. An efficient way to handle multiple conditions. Logical operators. Combine conditions to make your program smarter.
If you're learning C programming or just brushing up on your basics, today's video is super important. We are diving into control flow in C. Basically, how your code makes decisions. Think of it like giving your program a brain. So stick around, and by the end of this video, you'll be able to write smarter and more logical programs. Control flow is all about decision making in code. Without it, our programs would just run straight from top to bottom with no choices. But real life logic doesn't work that way. We make decisions constantly. If it rains, take an umbrella. If you're hungry, eat lunch. C gives us the tools to perform that same kind of logic with if, else, else if, and instead if statement. We'll go through them one by one, starting with the simplest, the if statement. The if statement is your first tool to add logic into your program. Its job is simple. Run a block of code only if a condition is true. Here's the syntax. This is the basic structure of an if statement in C. It starts with the keyboard if, followed by a condition inside parenthesis. If the condition is true, the block of code inside the curly braces is executed. If the condition is false, the code inside is skipped. Think of it as a checkpoint. The program asks, if this condition true? If yes, it moves forward with the code inside. Otherwise, it ignores it completely. Here's a simple C program that demonstrates how the if statement works. First, we declare an integer variable a and assign it the value 10. Then we use an if statement to check if a is greater than 5. Since 10 is indeed greater than 5, the condition is true. So the program enters the if block and executes the printf statement, which prints a is greater than 5. Finally, the main function returns 0, indicating that the program ends successfully. Basically, if the condition is true, we enter the block and print the message. Otherwise, we skip right past it. Think of it like a gate. If the condition passes, you walk through. If not, you turn away. But what if you want your program to take a different action when the condition is false? That's where the else statement comes in. This is the structure of an else statement in C. It begins with the if keyword followed by a condition inside parenthesis. If the condition is true, the code inside the first block just after the if gets executed. But if the condition is false, the program skips the block and moves to the next else block instead, executing the alternative code. Think of it like a fork in the road. If the condition is true, go one way. If not, take the other path. Let's see one real life example. Imagine a bouncer at a club. If you're 18 or older, you're allowed in, else you're told to go home. Here's a simple C program that uses else statement to check if someone is eligible to vote. We start by declaring an integer variable named age and assign it the value 15. Then we use an if statement to check if the age is greater than or equal to 18. In this case, 15 is less than 18, so the condition is false. That means the program skips the first block and executes the code inside the else block. As a result, it prints "you can now vote." Finally, the main function returns 0, indicating the program ends successfully. Sometimes it's not just yes or no. We've got multiple options. Let's say you want to assign grades based on marks. You'd use an else if ladder. This is a structure of an else if ladder in C. It starts with an if block that checks the first condition. If that condition is true, the corresponding code runs and the rest is skipped. If the first condition is false, the program checks the next condition in the else if block. If that one is true, it runs that block instead. You can have as many else if blocks as needed. Finally, if none of the conditions are true, the else block at the end serves as a fallback. It runs only when all other conditions fail. The structure is perfect when you have multiple possibilities and need to pick exactly one based on conditions. In this program, we are checking a student's grade based on the marks. We've stored the value 75 in the marks variable. The program starts by checking if the marks are greater than or equal to 90. If so, it prints grade A. Since 75 is not greater than or equal to 90, it skips that block and checks the next condition. Is it greater than or equal to 75? This one is true, so it prints grade B. The remaining conditions are skipped because only one block in an else if ladder executes. This kind of grading logic is common in real world applications like report card generators or result portals. The program checks each condition in order. As soon as one condition is true, it stops right there and executes that block. So it's like a filter checking one level at a time until something matches. Next up, nested if statements. This is when you place one if inside another to build layered decisions. So here you have a syntax of a nested if structure. An if statement inside another if. First, the program checks condition 1. If that condition is true, it moves into the next block. Inside that block, it checks condition 2. If both conditions are true, then the innermost code is executed. This structure is useful when one decision depends on another. For example, checking if a user is logged in and then checking their access level. But remember, nested conditions can make code harder to read, so use them only when necessary. Here's a classic example of a nested if statement in C. We start with two variables, age set to 25 and gender set to if. The outer if checks if the person is older than 18. Since 25 is greater than 18, this condition is true. Now inside that block, we check another condition, whether the gender is F. If it is, the program prints adult female. Otherwise, it prints adult male. This nested structure allows us to make a decision within a decision, which is perfect for situations like categorizing users based on multiple criteria. And since both conditions are true in this case, the output will be adult female. Common mistake number 1: placing a semicolon right after the if condition. Take a look at this code. That semicolon ends the if statement immediately. So what happens next? The line below the print statement runs no matter what, even if x is not greater than 0. Why? Because the if doesn't actually control that line. It's already been terminated by the semicolon. So the fix is simple. Don't add a semicolon after the if condition. Let the block of code inside the braces do the work. Common mistake number 2: forgetting to use braces after an if statement. Let's say you have this code. At first glance, it might look like both print statements are part the if. But here's the catch. Only the first line is controlled by the if. The second printf is outside the condition and will always run whether x is greater than 0 or not. To fix this, always use curly braces if your if block has more than one statement. This way, both statements only execute if the condition is true. Common mistake number 3: using assigning operator instead of comparison operator in a condition. Take a look at this code. It may seem like you're checking if x is phi, but what you're actually doing here is assigning phi to x. And in C, an assignment returns a value, in this case phi, which is true. So the if block always runs, even if that's not what you intended. To properly compare values, use comparison operator. Common mistake number 4: the dangling else. This happens when you have nested if statements without using braces. It becomes unclear which if your else belongs to. C always pairs the else with the closest unmatched if, which might not be what you intended. The solution: always use braces to make your intent clear. This way, there's no confusion and your code becomes more readable and less error prone. So let's go through some real world examples. The first one: menu selection in apps. In many applications, especially games, you've often had a menu where the user selects what they want to do. For example, if the user chooses option 1, the program starts a new game. If they choose option 2, it loads a saved game. This is where control flow using if and else if helps guide the program based on user input. Second one: ATM program logic. In an ATM program, control flow plays a key role in ensuring security. For example, the program first checks if the entered PIN matches the correct one. If the condition is true, it shows the transaction menu. If it's false, it displays an error message. This kind of conditional logic is critical for real world applications like banking. Next one, games or quizzes. Let's say you're building a quiz game. You ask a question and the user selects an answer. If the selected answer matches the correct one, say option B, you increase their score. This is a practical use of if statement in interactive applications. So let's do a quick recap. If executes code if condition is true, else executes if condition is false, else if checks multiple conditions, nested if decision inside a decision. Avoid common syntax mistakes. Let's break down the C program step by step. This simple program calculates the price of a movie ticket based on the age of the person, using control flow statements like if, and else. The program begins by including the header file, which is necessary for input and output functions like printf and scanf. Then we define the main function, which is the entry point of every C program. Here, two variables are declared. Age is an integer that stores the user's age, and price is a floating point number that will hold the ticket price. The next part prints a message asking the user to enter their age. The scanf function takes the input and stores it in the variable age. The format specifier is used because age is an integer. Decision making using if-else condition. This first condition checks if the person is under 5 years old. If yes, the ticket is free, so the price is set to 0. If the age is between 5 and 12 inclusive, the price is set to Rs 50. We use the logic AND operator to check both conditions at once. If the age is more than 12 but less than or equal to 60, the person falls into the standard adult category and the price is Rs 100. Finally, if none of the above conditions are true, which means the person is over 60, they get a senior citizen discount and the price is Rs 60. This line displays the final ticket price using printf. The format specifier ensures that the price is shown with 2 decimal places. This returns 0 to indicate the program has executed successfully. So here's the output of this code. You enter your age 15. Since 15 is lesser than 60 and greater than 12, the price is given as 100. Let's walk through a simple but practical C program that stimulates the basic operations of an ATM. It includes PIN verification, balance checking, and withdrawing money. We begin by including the standard input-output library, that is the header file, which gives us access to functions like printf and scanf. Here's the main function where our program starts running. We declare and initialize a few variables. PIN is the correct ATM PIN. Hard-coded has 1, 2, 3, 4. Entered PIN will store whatever the user types in. Balance is initialized to 5000 rupees. Choice will hold the user's menu option. Amount is the withdrawal amount. Here we prompt the user to enter their PIN and store the input in the entered PIN variable using scanf. We then check if the entered PIN matches the correct one. If it does, the user is allowed to proceed. Next, we display a simple menu with three options: check balance, withdraw money, and exit. The user enters their choice, which we store in the choice variable. If the user chooses option 1, the program simply prints the current balance. If the user selects option 2, we ask how much they want to withdraw and store that in the amount variable. If the amount is greater than the balance, the program warns the user about insufficient funds. If the withdrawal amount is less than or equal to the variable balance, we deduct it and print the updated balance. If the user enters option 3 or any other number, we assume they want to exit and we thank them for using the ATM. If the pin entered at the beginning doesn't match the correct one, the program denies access and stops there. Finally, the program returns 0, signaling that it ended successfully. Now, let's run the program. First, the pin is asked. We enter the pin 1, 2, 3, 4. Now 3 choices are given. Choose any one of them. Here, the second choice is chosen, that is the withdrawal. Now enter the amount that needs to be withdrawn, 600. So 600 is deducted and the remaining balance is shown, that is 4400. This is a simple menu-driven calculator that performs the 4 basic arithmetic operations based on user input. We start by including standard input-output library, header file which gives us access to printf and scanf. Then we declare main, the entry point of our program. We declare 3 integers a and b to store the 2 numbers and choice to capture the user's operation selection. We then prompt the user to enter 2 numbers and read them with scanf using the format specifier. Next, we print a menu listing the 4 operations and ask the user to select one by entering a number from 1 to 4. We read the choice into the choice variable. We then use an else if ladder to determine which operation to perform. If the user choose 1, we add a and b and print the sum. If they choose 2, we subtract b from a and print the difference. If they choose 3, we multiply a and b and print the product. For division, that is choice 4, we include a nested if to guide against division by 0. If b is not 0, we cast a to float and divide, printing the result with 2 decimal places, otherwise we display an error message. If the user enters any number other than 1 to 4, the final else block catches it and prints invalid choice. Finally, we return 0 to indicate successful execution. The output of the program, we have to enter 2 numbers, choose any operation, and we get the product. Let's find out the output of this program. So first we set A to 10 and B to 20. We check if 10 greater than 20, that's false. So we do not enter the inner if block at all. Because the outer condition is false, control jumps to the else that pairs with if, not the inner one. That else runs this line. As a result, the program prints 3. Let's go through the simple C program step by step. First, we begin with a declaration. So the value of x is initialized to 6. Now we move on to the first if condition. This checks whether x is divisible by 2. Since 6 is divisible by 2 equals 0, the condition is true. So we enter this block. Inside that block, there is another if statement. This checks if x is divisible by 3. 6 divided by 3 is also 0. So this condition is true as well. Since both conditions are true, the program executes and prints divisible by 2 and 3 as the output. So let's start with this program. We begin with the initialization. So A is 0 B is 1 and C is 0. Now we move to the if condition. The key thing to understand here is how the logical operators work, particularly the AND operators and OR operators. These operators evaluate expressions from left to right, but let's see step by step. So A post increment is evaluated. The value of A is 0, but post increment means A will be increased after its value is used in the expression. Since A is 0, the expression is false. Now A becomes 1 due to the increment. Next, B post increment and C post increment is evaluated because of the OR operator. Since A was false, we need to evaluate the second part of the expression. First, B is evaluated. The value of B is 1. So B post increment is true. Then B is incremented to 2. Now we need to evaluate C post increment because of the AND operator. C is evaluated and the value of C is 0, which is false. So C increment is false. Then C is incremented to 1. Now the entire condition becomes A post increment is false, but B post increment and C post increment is false as well. Therefore, the entire condition is false. Since the condition in the if statement is false, the program enters the else block and executes else block. Let's analyze this problem. We begin with the variable declaration. So the value of x is 5. This checks whether x is equal to 5. Since it is, the condition is true and it prints 5. Next, this is a separate if else block, not connected to the previous one. X equals 6 is false because x is 5. So the else block is executed, printing not 6. So the final output will be 5, not 6. We start with the variable declaration. So A is 5 and B is 10. Now we begin evaluating the nested if statement. A is 5, which is greater than 0, so this condition is true. We move inside this block. B is 10, which is greater than 5, so this condition is also true. We go one level deeper. A is exactly 5, so this is true as well. So the program prints X. That's a wrap on control flow in C. Hope this video helped you. Thank you for watching.